Now let's have a look at the circle. This is, you know, we need to have a good base in this. Like, there's going to be a lot of problem solving, because not only can you be asked about the circle, but you can also be asked about tangents to the circle or chords on the circle, loads of things. That means they're mixing coordinate geometry of the line, because a tangent is a straight line, a chord is a straight line, and coordinate geometry of the circle. So let's just, for the minute, have a look at the circle, and then we'll have a look at how they can kind of mix the two kind of sections together, and that will be probably a good lot of problem solving when they start mixing the two together. So again, you need to get familiar with your log tables. You have here the equation of a circle. Both of these are the equation of a circle. This is if it's given in this format. So perhaps you get the equation of a circle and it looks like this. Well, because it's in this format here, you're hopefully hoping to read and just be able to pick out what H is and what K is and what R is. So if we look here, the X and the X match, the minus and the minus match, the 3 and the H match. So H has to be 3. The Y and the Y match. Okay, so the minus and the plus don't. So what's a minus made up of? Or sorry, what's a plus made up of? It's a minus and a minus. So the Y and the Y match, the minus and the minus match, K must be a minus 2. And then R squared is 25, so R has to be 5. Now if I read exactly what's going on here, it tells me that if it's in this format and you can pick out H and K, then H and K are the centre of your circle. So the centre of my circle is 3, 2, and the radius is 5. Why do I want those? Well, it only makes sense that if you ever want to draw a circle, the basic requirements that you need, like the minimum things that you need, are its centre point and the length of its radius. Because then you can get your compass, put the pin of your compass onto your centre point, lengthen out your compass to the length of the radius and draw your circle. So it's very important that if you're given the equation of a circle, that you're able to find the length of the radius and that you're able to pick out the centre point. And vice versa, if you're given the length of the radius and you're given the centre point, you should be able to put it into this format and have the equation of a circle. The benefit of having it in this format here is that you can really fast, it's very fast to pick out the centre point and the radius length. However, are you always going to get it in that format? No, so let's look at the exact same circle. X minus 3 to be squared plus y plus 2 to be squared is equal to 25. It's possible that like this could all be squared out when you get it. So if it's all squared out, so that's, if I squared this part out, that's x squared minus 6x plus 9 plus y squared plus 4y plus 4 equals 25. If I bring everything to the left, x squared plus y squared minus 6x plus 4y plus 9 plus 4 is 13, plus, minus the 25 when I bring it over is minus 12, I think. So maybe you don't get it in this format. Maybe they already have it multiplied out and it's in this format. If that's the case, then you need to look at your log tables. If the equation is given in this format, you need to figure out what G, F and C are. And when you know G, F and C, you'll be able to figure out your centre and your radius, but it's very important that you figure out G, F and C. So if we, again, we compare, then I can clearly see that matches with that matches with that. The 2G matches with the minus 6, which means G is minus 3. The 2F matches with the 4, which means F is 2. And the C matches with the minus 12. Now that I know that, I can go back to my log tables. It says if you want the centre when it's in this format, minus G minus F, well, I know that G is minus 3, so minus G is 3. F is that, so minus F is minus 2. And it also says that if you want so that's the center point, if you want the radius length, you need to get the square root of g squared plus f squared minus c. So we have the square root of g squared plus f squared minus the c, which gives me the square root of 9 plus 4, which is 13, plus 12, which is 25, which is 5. So it doesn't matter what format you're given it in, you should be able to go to your log tables. If it's in this format, be able to pick out h and k and your radius, and then you'll know your center and your radius. And if it's in this format, pick out g and f and c. And then if you have g and f, well then you have your center, because you can just get minus g and minus f. And if you have your radius, you can get your radius by going the square root of g squared plus f squared minus c. Benefit of this one is it's already multiplied out. Sometimes in a question you'll want to multiply this out, whereas if you put it into this format, it's already multiplied out for you. Just so you're aware, we don't use, like you're not taught how to use this formula here or this formula here. It doesn't mean if you choose yourself to use them in the exam that you'll be penalised. You won't. You can use them if you want to use them in the appropriate place, but it's not on your course, so you're not taught how to use it, but you can if you really wanted to, or if you were very stuck and didn't know what to do. Right, so that's... Now you'll find a few questions in your exam, just even basic questions about finding the center of the circle and the radius length. Like, it is important that you're able to do it. And I guess it might just be good to notice that x squared plus y squared plus 25 equals 25. Like, this is, if you thought back to what the center of this circle might possibly be, it must have looked like this at some point. Or the equation of this circle, it must have looked like that. Because if you go x minus 0, that's x, and you square it, plus y minus 0, that's y, and you square it. So the centre of this circle must be 0, 0, and the radius must be 5. So just be aware of that. Now, if I give you this question, I don't ever really get used to seeing a 3 in front, so why not divide across by 3? And then they're actually the same question. So put it in the form that you're used to. I mean, if you think back to the equation of a line, we get used to putting it into a certain form. That's fine. Just get used to putting it in the form that you're used to seeing it in, and then try and figure out what the center of your circle is and what the radius length is. Don't think that you have extra to learn in this topic. It's not like that. You know, it's how do you find the point of intersection between two lines? You use simultaneous equations. So how do you find the point of intersection between a circle and a line? You're going to use simultaneous equations. So if I asked you to find the point of intersection between a line and a circle, you have to be, like, your algebra has to be good. Let me just find the question here so I can just get the idea. Okay. So the question here that says determine if the line 4x minus 3y equals 31 is a tangent to this circle. And you know, there's always a few ways around it, so don't think that you have to do this the exact same way I'm doing it. But I think that if this is a tangent to this circle, there's only going to be one point of intersection. So I potentially would try and use simultaneous equations to do this. Now, if you're going to do simultaneous equations and you think that it's, you know, the point of intersection is going to help you, well, this only requires algebra now. So as I said, you need to manipulate this around. Like, you have to be able to recognize what type of simultaneous equation. So for me, this is the leaving cert type, where you take the easier equation, you move it around until you get x or y isolated by itself. So if I isolate the x, I'd end plus plus 31 over 4. So anywhere I have an x, now I might replace it with what I know it to be equal to. So that's my simultaneous equations method. I also can straight away pick out the center of the circle, and I could figure out the radius length. So the center of this circle, when you look at it and work it out, is going to be 3, 2. And the radius length, when you work it out, is 5. So what you could do, another option here, is you could find the perpendicular distance from that point to this line here, and if it's equal to 5, well then it's a tangent. If it's greater than 5, it's not a tangent. It means that the circle and the line don't intersect at all. And if it's shorter than 5, well then it means that it's cutting across or through your circle. Whatever way you can figure out and problem solve to do this, then that's how you're going to try and get about it. So if, like I said, when we're problem solving here, if they mention a formula, do it. So, you know, they asked me, is it a tangent to the circle? And I just tried to think, right, how many different ways is there of saying that? A tangent only touches the circle at one point. Or a tangent is, so that's why I did that's why I did simultaneous equations, to find that point of intersection and show that there was only one. However, if I'd said it the other way and talked about, you know, a tangent is a perpendicular distance of 5 from the center, well then I might have used the perpendicular distance formula. So saying the question in different ways is going to be beneficial.